Hello everyone, welcome back to this online class. My name is Francis Okech and my YouTube channel is Professor Francis Okech. Today we are going to look at Calculus 2 and our main topic is on applications of definite integrals. In particular, we are going to see how to find the length of an arc. So let's consider the graph of the function. You can write consider the graph of the function. Our function here is y is equals to f of x between, that should be between x is equals to a and x is equals to b. So I'm going to sketch it. I'm going to sketch that graph. Let's say we have something like this. On the y-axis and the x-axis, and our graph is something like this one. Y is equals to f of x. I want us to consider the portion between point A and point B. Now, let's say this is point A, capital, and this one is point B. If I extend this horizontally and this one vertically in this manner, you see those two lines are going to meet at 90 degrees. So at this point is the point A and this other point is B. Now, the length, the distance from A to B, we are going to denote that by dl. It's a very small portion. So the distance from here, let's say this is a point, we can call it point M, so that A to M there, we denote that by dx, a change in x, that should be d, dx, change in x, and this other side is change in y. This one is change in L. We have taken a very small portion on the graph of y is equals to f of x. Now look at what we are forming. If I join A to B straight away using a straight line, that is like the length of that straight line is almost approximately equal to the arc length AB, as you can see from the diagram. So look at that triangle, it's a right angle triangle. So we are using Pythagoras theorem. So when you use Pythagoras theorem, you note that from that triangle, hypotenuse squared, the L squared is equals to the x squared plus the y squared. That's what we have. Now I want to make the L the subject. So from here, you can now say that dl is equals to the square root of dx squared plus dy squared, which can also be written as, if you factor out dx, you're going to get 1. You factor out dx squared, that will be 1 plus dy over dx. This should be squared Then there's dx squared. Let me use the same opening bracket as that of closing. Here we have this kind of a bracket, then times dx, and this is supposed to be squared. Everything inside the square root. And so that can as well be written as, you can also write this as the square root of 1 plus dy over dx. Dy over dx, and this is squared, times the square root of dx squared, which you can as well write as the square root of 1 plus dy over dx. This is squared. Remember here there's a closing bracket. Then times dx. Dx is now outside the square root. So now, remember, when we write dl, is a very small change in that length. Dx is the small change in x, and dy is the small change in y. So then if I want to find L, you now integrate both sides. From x is equals to a to x is equals to b. So integrate, can just say hence, if I want to find, remember, take note that the integral of the L is the same as L. So we integrate both sides from x is equals to a to x is equals to b to get L is equals to the integral from x is equals to a to b of the square root of 1 plus dy over dx. This is squared. That is the end of that square root. Then it means we are integrating that with respect to x. This formula that I have written here is the arc length formula. This is the formula that you're going to use to be able to find the length of the arc. It is the arc length formula. So take note of that formula, where L is the length of the arc. L there denotes the length of the arc, which joins point A and point B along the curve y is equals to f of x. Now I want us to take note. What if your x and y are given as parametric functions? So we are going to take note, NB. You can write that if x is a function of t and y is also a function of t, it can be t, it can be theta, as long as they are defined parametrically. Then that is from, you can just say then, for t in the interval t1 to t2, we have, in that case, your arc length will now be the integral from t is equals to t1 to t is equals to t2 of the square root dx over dt. This is squared plus dy over dt squared. Integrate that with respect to t. So that is when you have your curve defined in terms of a parameter. It could be t, it could be theta. If there are functions of theta, where there is t, you put theta. So, having looked at those two formulae, let's look at some examples of how to calculate the length of the arc of any given curve. So we look at examples. You write examples. And here, you are asked to find the length of the curve. I'll start with the simplest. Find the length of the curve y is equals to x cubed over 6 plus 1 over 2x from x is equals to 1, from x is equals to 1 to x is equals to 2. That's what we have. So look at our formula. We need to find dy dx. So we start by differentiating. Solution dy dx is equals to differentiate x cubed, that is 3x squared, then you divide by 6. So that is 3x squared over 6. Differentiate, remember this is 1 over 2 times derivative of 1 over x is negative 1 over x squared. And this you can write as x squared over 2 minus 1 over 2x squared. So that is our dy dx. Now I need to find dy dx squared. Remember this 1 over 2 is common, so you could factor out 1 over 2 so that we have x squared minus 1 over x squared. So you can now say that dy dx, and this is now supposed to be squared, is simply 1 over 2 x squared minus 1 over x squared, and the whole of this is squared, which can be written as now 1 over 4. 1 over 2 squared is 1 over 4. X squared minus 1 over x squared squared. That's what we have. And you can open that bracket. When you square, you're going to get 1 over 4 x raised to 4. Remember, a minus b squared. That's what I'm using. A minus b squared. That's the same as a squared minus 2ab plus b squared. You take note of that. So, in this case, our a is x squared and our b is 1 over x squared. So twice of that, that would be minus 2. Because when you multiply a and b, those would cancel, that's 1. Then plus 1 over x raised to 4. So now let's add 1 plus dy over dx squared. So we need 1 plus dy over dx, and this is squared, is simply 1 plus our answer, 1 over 4 into x raised to 4 minus 2 plus 1 over x raised to 4, which you can write as 1 over 4 into 4 plus x squared minus 2 plus 1 over x raised to 4. And so this is equals to 1 over 4 in bracket. This is x raised to 4. Take note of that. X raised to 4 plus 2 plus 1 over x raised to 4. And so when you factorize, this bracket is the same as 1 over 4 x squared plus 1 over x squared. When you factorize, you get that this is squared. And so that's our 1 plus dy over dx squared. So I need the square root. So you can now say that the square root of 1 plus dy over dx squared is simply the square root of what we have found, 1 over 4 x squared plus 1 over x squared, and this is supposed to be squared. So that square root should give us 1 over 2 x squared plus 1 over x squared. That's what you get when you find the square root. Now with that, now it's now easy to find the arc length. Remember, arc length is just the integral of that square root from x is equals to a to x is equals to b. In this case, our a is 1 and our b is 2. Now, arc length is now the integral from x is equals to 1 to 2 of what we have found, 1 over 2 x squared plus 1 over x squared dx. 1 over 2 is a constant. You can factor that out. X is equals to 1 to 2 of, now we have x squared plus, remember x, 1 over x squared is the same as x raised to negative 2. And this is now integrate with respect to x. So when you work it out, what do you get? You're going to get 1 over 2. Use power rule. This will give us x cubed over 3 plus, that will now be, because negative 2 plus 1 is negative 1. So that is negative, or simply plus, x raised to negative 1 over negative 1 from 1 to 2. And so you can also write this as 1 over 2 x cubed over 3 minus 1 over x from 1 to 2. Let's plug in the limits. What will we get? We start with the 2. So we are going to get 1 over 2. When I put 2, I'm going to get 2 cubed is 8. So that's 8 over 3 minus 1 over 2. Subtract, when you use 1, I'm going to get 1 over 3 minus 1 over 1, that is 1. And so you can now press this in your calculator. Just simplify. Remember, this can as well be written as 1 over 2 into 8 over 3 minus 1 over 2 minus 1 over 3 plus 1. When you press, what do you get? You can as well press it. So I will start with the 8 over 3 minus 1 over 2 minus 1 over 3 plus 1. That should give us 17 over 6. Then this times 1 over 2. So it is 1 over 2 times 17 over 6, which will give us 17 over 12. That is the length of the arc, and this is units. Length is measured in units. Now, let's see another one where The curve is defined in terms of a parameter called be t, called be theta. Let me use the parameter t. So example 2. Example number 2. And in this example, you are asked to find the length of the curve. Find the length of the curve. X is equals to 2 cos cubed t, 2 cosine cubed of t, and y is equals to 2 sine cubed of t. Between the points corresponding to t is equals to 0 to t is equals to pi over 2. So you can write from t is equals to 0 to t is equals to pi over 2. That's what we have. Solution. Now we are going to use the second formula. Look at our second formula where we had x being a function of t and also y being a function of t. So we are going to use this. I need to know dx dt, dy dt, then you square them, then you add the results and take the square root of your result. So let's work it out. We're going to write dx dt. What is it equal to? Start by differentiating the power. Use direct chain rule. So that will give us 6 of cos 2 times 3 cosine squared t times derivative of cos t is negative sine t. And so this is the same as writing negative 6 cosine squared t times sine t. What about dy dt? Dy dt, that should again be equal to 3 sine squared t times derivative of sine t, that is cosine of t. And so this is the same as 6 sine squared t cosine of t. So we have found dx dt and dy dt. So let's square each of them. So from here, we'll have dx dt squared. You square that, that will give us 36 cosine raised to 4 of t times sine squared t. We're just squaring. And the other one, dy dt squared. Again, this should give us 36 sine raised to 4 of t cosine squared t. So now we add them, dx dt squared plus dy dt squared. So you can write dx dt, and this is supposed to be squared. Add this to dy dt, and this is squared. What are we going to get? It's just the sum of those two. That will give us 36 cosine raised to 4 of t times sine squared t plus another 36 sine raised to 4 of t cosine squared of t. And you see 36 is common. So that could be factored out so that this thing can now be written as, look at what is common. So we factor out everything that is common. I can see there's 36 common. What about cos squared t is also common. Cos squared t is common, and even sine squared t is common. So what do we remain with? Here we'll now have cos squared t plus sine squared t. Now you need to recall those trigonometric identities. You know that cosine squared theta plus sine squared theta should always be equal to 1. Cos squared t plus sine squared t should also be equal to 1. So you can just write but cosine squared t plus sine squared t must always be equal to 1. So in short, this can now be written as 36 cos squared t times sine squared t. Now I need to get the square root. So now the square root of the answer, now dx over dt squared plus dy over dt squared. This is simply the square root of what we have, 36 cos squared t sine squared t, which you can write as 6 cos t sine t. And how else can you write this? This is the same as writing 3 times 2 cos t sine t. And what is 2 cos theta sine theta? That is sine 2 theta. So 2 cos t sine t is sine 2t. So this is the same as 3 times sine 2t. I have used this identity that sine 2 theta sine 2t is the same as 2 sine t cos t. Those identities are very important. So now that we know that square root, so we are going to integrate our answer from t is equals to, let's see, from the question, t is equals to 0 to pi over 2. So let's now integrate. It's now easy to integrate so that we find the required arc length. So now you're going to say that therefore the arc length L, therefore, let me use another color. You can just say that therefore our arc length L is equals to the integral from t is equals to 0 to pi over 2 of the answer, that is 3 sine 2t dt. And now 3 is a constant. 3, you can factor that out. The integral from t is equals to 0 to pi over 2 of cosine of 2t dt. So this is equals to 3 outside. When you integrate, what did we differentiate to get cosine 2t? Remember, when you differentiate sine, you get cosine. So we expect the answer here to be sine. No, here we are integrating sine, not cosine. So there's a slight correction. instead of cosine here, it was sine. Somebody might be asking, why is it changing from sine to cosine? Let it be sine. That was a slight correction. So now you need to ask yourself that what did you differentiate to get sine? It's negative cosine. Because when you differentiate cosine, you get negative sine. So when you differentiate negative cosine, you're going to get positive sine of 2t, and this should be divided by 2. From 0 to pi over 2. This you can as well write as 3 over 2, of course negative 3 over 2. Then inside we have cosine of 2t from t is equals to 0 to t is equals to pi over 2. Remember, pi over 2 is 90 degrees. So this negative 3 over 2, and inside here we now have cosine 2t, 2 times pi over 2, that is pi, cos pi minus cos 0. Cos pi minus cos 0. And pi here is 180. So what is the cosine of 180 degrees? That is negative 1. So this is equals to negative 3 over 2. Cos pi is negative 1. And cos 0 is 1. So it's like we have negative 2. So we'll have here negative 3 over 2 times negative 2. And so the result there is 3. So the length of that arc is equal to 3 square units. So you can just write here as 3 units. Not square units. Square units is when you deal with areas. When it is just arc length, you write units. So I have taken you through the two formulas of finding arc length depending on how your curve is defined. So I wish if you're given any other question involving arc length, you should be able to tackle it depending on whichever function you're given, whether it is implicit, parametric, explicit, etc. So thank you all for watching this video. Please don't forget to subscribe to my YouTube channel. That is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you will find me right there. Also, comment, like, and share this video. When we meet next time, we look at other applications of integration. Bye-bye.